Hello viewers, so we have this question that says a particle moves along the x-axis and its coordinates vary with time according to the relation x is equal to t squared minus 2t, where x is measured in meters and t in seconds. A. Find the position of the particle at t is equal to 1 second and at t is equal to 5 seconds. Then B is saying find the displacement and the average velocity of the particle in the time interval 1 is less or equal to t, which is less or equal to 5 seconds. Then C is saying find the instantaneous velocity and instantaneous acceleration of the particle at t is equal to 3 seconds. Note to use the methods of calculus, which is differentiation. So let's see how we can solve this question. So we are given a position function which is x is equal to t squared minus 2t. And we're told to say we need to find the position of the particle when time is 1 second and also when time is 5 seconds. So when you are given a position function and they ask you to find the position, it means all you have to do is replace where there is t with the time you are given. So for the first part where they're telling us to find position when time is 1 second, we'll just say our x is equal to t squared minus 2t. So x at 1 second, we show that we are talking about the position at 1 second is equal to 1 squared minus 2, that is multiplying by 1 in that case. And then this will give us 1 squared is still 1, and then this is minus 2 by 1 is giving us a 2. So our position will be 1 minus 2, which is giving us a minus 1 meter. So this will be our position when time is 1 second. Then we do the same also for 5 seconds. We are still using the same function, which is x is equal to t squared minus 2t. Then our position when time is 5 seconds, so we show that this is equal to, where there is t we put 5, so 5 squared minus 2, that is also multiplying by 5 on the other side. And this will give us 5 by 5 is 25. So we'll have 25 minus 2 by 5 is 10. So this is giving us 15 meters. So our position when time is 5 seconds will be 15 meters. So that's how you solve the first part. So let's look at the second part. The second part is saying find the displacement and the average velocity of the particle in the time interval 1 to 5 seconds. So the first part is we're finding the displacement. As usual, displacement will represent it by S is equal to the final position minus the initial position, like that. Our final position is the position we found when time is 5 seconds. And we found that to be 15 meters. So we'll put 15 meters there. This will be subtracted by the initial position is the position we calculated when time is 1 second. So we found that to be minus 1 meter. So this is what we have here. And what we are getting is we'll have 15 meters. Then the minus multiplied by minus here, this minus multiplied by that minus will give us a plus. So we'll have a plus 1 meter here. And this is just giving us a 16 meters. Yes. So our displacement is 16 meters during this time interval, which is from 1 second to 5 seconds. So yeah, that's how you find your displacement. After finding our displacement, we're told to say we need to find the average velocity. So average velocity is equal to, we'll still say change in position over change in time. In this case, what we are saying is change in position is x final minus x initial, and this will divide by t final again minus the t initial. Replacing with what we have here, our x final is still 15 meters, like that, minus 1 meter, as we did earlier on. And then this will divide by our time. Our time, we have the final time to be 5 seconds. So we'll have 5 seconds minus 1 second that we established from our time in the question there. So when we do that, what we are getting is we're going to have a 16 meters on top there. This is dividing by 5 minus 1 is 4 seconds. And this will just give us 16 divided by 4 is giving us a 4. Yeah. So this is 4 meters per second. This is basically our average velocity. Yes. So the last part is the one that says find the instantaneous velocity and instantaneous acceleration of the particle at t is equal to 3 seconds. So given the position function, to find the velocity function, because for us to calculate instantaneous velocity, we need to find the function that represents velocity coming from the position function that we are given here, which is x is equal to t squared minus 2t. So we need to find the velocity function from this function here. So how do we do that? We need to differentiate this function in order for us to find the velocity function. In other words, we are getting the first derivative of this function in order for us to get the velocity function. So how do we do that? Now, when you differentiate, for example, if you have x to the power of 2, in case you don't know how to differentiate, what happens here is when you have a variable like that without a number in front of it, for example, this which we have here, 1x squared is the same as x squared. We have a 1 here. We don't just have to show it. So we have a 1 here. We don't just have to show it when it's a 1. So what is happening here is we are going to multiply. Okay, we multiply the power by the coefficient that we have here, and then we subtract the power by 1. So this is what we'll do. We'll say we're going to have x to the power of 2. When 2 multiplies by 1, we're going to get a 2. And then when we say minus 1 there, we're going to get x to the power of 1. So when we differentiate x squared, we are getting 2x like that is our answer. So differentiating means you are going to multiply the power that you have by the coefficient and then subtract a 1 from the power. And then what you find there is the derivative for that. Now, a derivative is an answer you get after differentiating. So when I say this is the derivative of x squared, it means this is the answer I'm getting after differentiating x squared. So yeah, this process is you multiply the power by the coefficient. The coefficient is the number written in front of that variable. And then you subtract 1 from the power, which we have done here. We multiplied 2 by 1, giving us a 2. And then we said 2 minus 1, giving us a power of 1, giving us this, which we have here. All right, so let's go ahead and see how we can do that. So what we have here is velocity is given as dx over dt, meaning we are differentiating the position function, which is x with respect to time. So this will be equal to our v is equal to d dt of the position function. Replacing with what we have here, this will be equal to our v is equal to d dt, like that, of the position function that we have, which is t squared minus 2t, like that. Then our v will be equal to, now, when we differentiate t squared, what we are going to get there is 2t. So we'll have a 2t. And then when we differentiate 2t, what we are going to get there is basically a 2. So meaning this is now the velocity function that we need to use to find our velocity. When we differentiate 2t, this t is like to the power of 1. So it's to the power of 1. When you multiply this power 1, when you multiply this power 1 by 2, we're going to get a 2. So we'll get a 2 when we do that. And then when we say this power minus 1, so we're saying 1 minus 1, this is giving us a 0. So we'll say this is x to the power of 0. Any number given to the power of 0 is 1. So what we have is 2 multiplied by 1, which is just 2. So this is why when we say 2t, when we differentiate 2t, we are getting just 2, which is this 2 here. This is what happened on this one. Yeah. So now that we have the function that can help us find velocity, let's go ahead and find that velocity. So I'm getting rid of this other part. All right, so to find our velocity, we'll say velocity is equal to 2t, which is the function we got, minus 2. And then all we have to do is just replace where there's t, we put our time. So the time given is 3 seconds. So we'll say 2 multiplied by 3 seconds minus 2. And this will give us 2 by 3 is 6. So we'll have 6 seconds minus 2, which is just giving us 4 meters per second. So our velocity will be 4 meters per second, like that. Remember, this is velocity and is measured in meters per second. Yes, so that's our answer for that part. And then the last part, we need to find acceleration. So to find the acceleration, we need again to get the first derivative of this function here. So we need to differentiate this function so that we get the acceleration function. We're still going through the same process. So let's do that. All right. So what we have there is acceleration is given by dv dt, meaning change in velocity per change in time. And what we have there is, we'll say we have our d over dt of the velocity function. And this will be equal to d dt of the velocity function, which is 2t minus 2, like that. So that's the function we are differentiating. And then our acceleration will be equal to, when we differentiate, now when we differentiate 2t, what we are going to get is 2. So we're getting a 2 there. And then when we differentiate a constant, what we are getting is a 0. So we'll have minus 0 there. So acceleration is equal to 2 minus 0, which is just equal to, so our acceleration will just be equal to 2 meters per second squared, like that. So that's our acceleration.